Welcome to our UPA MOOC technical drawing for mechanical engineering. We are now in Module 3, when we are going to talk about part drawing. This module will be divided in 3 units. Unit 1, we talk about constructive solid geometry, which is a methodology for part analysis. In Unit 2, we will study components of a part drawing. And Unit 3, we will take a view of the international standard for technical drawing. Now let's start with Module 3, Unit 1, Constructive Solid Geometry, Part Analysis Methodology. What is a part drawing? A part drawing is the document that describes clearly and precisely the geometry and way of manufacturing of a part. For this purpose, we use views, sections, and dimensions that finally deals to the manufacturing of our real part. What is constructive solid geometry, CSG? The idea is to divide the part into basic elements and to join them by Boolean operations. Operations like union, which means adding, and difference, subtracting, that constitute the principal operations. Geometric primitives, box, first element, are the simplest elements to construct a part. The part extrusion is made by a step. First, we need to select the principal element, in this case, the major cylinder. Second, we add in the top a small cylinder. The third step is to subtract the cylindrical hole to the prior conformation, and finally we obtain the final part. What is CSG useful for? We find often interpretation mistake in the technical drawings. This is because we don't know the correct origin of the part. In the top figures, has a cylindrical hole that derives in a distance. The bottom figure has a cut by 2 planes at a distance that derives in a circular imprint. It's completely incorrect to make dimensioning of the distance in the top figure and the diametral measurement in the bottom view. What is CSG useful for? Well, really allow us to follow the correct way that sets the dimensions of the original primitives and omits the derivatives dimensions. In the case of the sphere with a cylindrical hole, what we have to represent is the dimensions of the principal elements. In the other case, a sphere cut by 2 planes, we have the dimensions relevant to this situation. Let's now begin with the fundamentals of CSG. Original primitive sizing allocation. We initially part from the original primitives, in this case a cylinder and a sphere. We need to establish the size and location dimension for these primitives to constitute the first step of the analysis. Well, following with the CSG fundamentals, we have the Boolean operation. The first one is the union, that make in a unique volume the 2 primitives that before are sizing and location. Difference. In difference, we subtract to one primitive the volume or part of the volume of the other primitive. In this case, we have two possible solutions. Depends on which element subtract to the other. A less frequent Boolean operation is intersection, which means the common volume in between the two primitives that we have to describe the part. One of the fundamentals of the CSG is that the Boolean operations are not commutative. In this case, we have a part made from a sequence of operations. That is different. If we change the order of this operation, we obtain a different part from the initial. Well, geometric primitives are the basic elements for CSG. These are the basic and regular geometric solids: box, cylinder, torus, frustum, etc. Also, we have as a basic element of CSG the mechanical features. These are combinations of primitives that, for reason of standard, performance, or manufacturing, have a specific representation and dimensioning. Repetitive element, chamfer, fillet, dovetail, countersink are some examples of mechanical features. Let's now begin with a description of the principal primitives. First, the box. For sizing a box, we need three dimensions, that is, height, width, and depth. To represent the box, we need two views for placing the three dimensions of the box. Linear location could need up to 3 dimensions. An angular location could need up to 3 dimensions, but this is in very rare case. The reference for location dimension could be corners or symmetry planes of the box, depending on the rest configuration of the part. The second primitive, the cylinder, is the most frequent primitives in technical parts. Its size needs 2 dimensions, diameter and height. And as a revolution body, its representation only needs one view, the parallel to axle 1. Linear axis location will need up to 2 dimensions. Angular axis location will need up to 2 dimensions. But the angular position of the primitives is a situation that hardly occurs. The reference for location dimension must be normally the axle. It's not correct to refer to curved contours. Frustum. Sizing a frustum needs 3 dimensions: minor diameter, major diameter, and height. As a revolution body, representation only needs one view, the parallel to axle 1. As cylinder, linear and angular location will need each up to 2 dimensions, but linear occurs very frequently and angular is a very rare situation. The reference for location dimensions must be the axle. It's not correct to reference to curved contour. Torus. This revolution primitives needs two dimensions for its sizing. First, guideline diameter, and second, generatrix diameters, that is, the tube diameter. It's a revolution body, we need only one view. The reference for location dimensions must be the center of the torus. Hexagonal prims. This is not a curve, this is a facet, a planar facet geometry, but very used in the technical parts. Its sizing needs two dimensions, height and distance between parallel faces, because that fits the dimension of the spanner. For representation, it's obligatory the view of the regular hexagon and one view more for the height of the parallel to the height of the hexagonal prims. The reference for location dimensions must be the axle. It is not correct to reference to vertex or hexagonal sides. A sphere. Sizing a sphere needs only a dimension. Its location will need up to 3 dimensions. There is no sense in angular locations. To find a single sphere hardly occurs. Now, let's summarize Module 3, Unit 1. What have we learned? Apart drawing the script precisely apart. CSG, this methodology, divides apart into basic elements and join them by adding and subtracting. CSG allows us the correct path representation. The basic types of elements are geometric primitives and mechanical features. The common primitives, box, cylinder, frustum, torus, hexagonal prism spheres, has specific dimensions and reference.